In this lecture on the introduction to Raspberry Pi, you will learn about what Raspberry Pi is, what are the different functions of Raspberry Pi, and more importantly about why Raspberry Pi is so important in the development of IoT. So, Raspberry Pi compared to Arduino is more powerful. It is more powerful in terms of the computation or processing power. Additionally, it has better memory capacity, and also it can integrate different types of sensors and actuators, and this part is more attractive than compared to the similar kind of feature of Arduino. So, we can do different types of sensors integration in Raspberry Pi, and due to the feature that it can process more compared to Arduino, it has better processing capabilities and more features and so on. This is particularly attractive for sensors which require more processing. For example, imaging sensors, multimedia, different types of multimedia sensors which require more processing, this sort of device becomes more useful. So, in the same way as we can have an Arduino based IoT node, here also we can have, using Raspberry Pi, we can have a Raspberry Pi enabled IoT node, and this IoT node would be more powerful compared to the Arduino based node. Additionally, we have to keep in mind that although it has better capabilities, but it comes at more cost. The cost of purchasing Raspberry Pi is more than the cost of Arduino in general. So, there is a trade off, of course. However, it all depends on the requirements. If the requirement of the particular IoT application that is being developed is to have some nodes which which should act as a server, then Raspberry Pi would be a better option than Arduino. Second thing is that with Raspberry Pi you can configure Raspberry Pi as a web server. You can even configure Raspberry Pi as an edge device, and so on. So, there are different capabilities that are there, but at the same time more computation means more power consumption. So, if you have the same kind of application with more power consumption requirements, etc., and if that is not a problem, then one can go for Raspberry Pi. However, this particular issue is a little bit tricky, because there are certain scenarios where Arduino can also come to be beneficial with respect to this. So, we are going to go through the different aspects of Raspberry Pi and try to understand how Raspberry Pi can be used. So, as I said before, if you have a Raspberry Pi module along with you, you can practice as we explain to you the different steps, the different features and so on. In this lecture and the subsequent one, the next one, in both of these we are going to teach you about Raspberry Pi. So, I have along with me my TA for this course, Mr. Anandarup Mukherjee. Like the previous few lectures, he is going to take you through the hands-on aspects of Raspberry Pi.
Hello, today this lecture will cover an introduction to Raspberry Pi. So, this will be again a two-part lecture. In the first part will cover the basic introduction to what is Raspberry Pi, the hardware system, and how you go about installing basic operating system on the Raspberry Pi and how to access that device. So, what exactly is a Raspberry Pi? It is basically a micro-sized computer. Commonly, in common terms, it is said as a computer in your palm. More specifically, it is a single board computer which is very low cost device and which is very easy to access. So, these are one of the main reasons, these are some of the main reasons why Raspberry Pi has become so popular with respect to IoT as well as hobby electronics people. So, there are various variants of Raspberry Pi. So, some common variants are you have the newest Raspberry Pi 3 Model B, then Pi 2 Model B, Pi 0. So, these are the ones most commonly being used. So there are other variants also, but these three can be considered as the main market holders. So as you can see, the RAM requirements for Pi 3, Pi 2 and Pi 0, for Pi 3 it is 1 GB, Pi 2 it is 1 GB, whereas for Pi 0 it is bit lesser at 512 MB. The CPU is a quad core Cortex A53 processor. Processing speed is approximately 1.2 GHz, whereas for Pi 2 it is 900 MHz. GPU requirements, you have on Pi 3 400 MHz of video core, 250 MHz video core for Pi 2 and 250 MHz again for Pi 0. You have provision for Ethernet on Pi 3 and Pi 2, whereas there is no provision for either Ethernet or Wi-Fi on Pi 0. Yes, there is a provision for Wi-Fi and Bluetooth only on mod Pi 3. Generally video output is from HDMI port, and there are 40 GPIO pins. So these GPIO pins are mainly known as general purpose input output pins. So this is the basic functional architecture of a Raspberry Pi. So at the center you have a CPU or GPU. You have various input output ports connected to it. You have a RAM. You have a USB hub from which you can connect an Ethernet, as well as you have various USB ports to which you can connect regular USB devices. So in short, this thing is as similar to your normal PC, right? So this is the picture of a Raspberry Pi. So I have one Raspberry Pi with me right now. So if you can see, this is a Raspberry Pi 3 Model B. So over here you have one HDMI port. This small port is for the power adapter. These are the GPIO pins interlaced with some power pins like 5 volt, 3.3 volt and ground. And you have this processors. This is the ARM based processor. You have 4 USB ports, you have one Ethernet port. So and you have one sound card output also. And turning it over to the other side, you can see there is a small memory card attached. So if you take it out, so we are using a 32 GB memory card, but generally 8 to 16 GB memory cards are sufficient. So the main function of this memory card is it actually holds the OS of the Raspberry Pi. So first step towards initializing Raspberry Pi is you download the OS available freely online. You load the OS on the memory card and you just plug this thing into your memory card slot on the Raspberry Pi. So it goes like this and your system is ready. Then we need some basic configurations to get this up and running and available on the network. So once your system is up and running, you can see you may access the Raspberry Pi based OS, which is primarily a GUI based system. So it is quite similar to your normal Ubuntu based systems. So you can see you have various programming languages which are already available within this. You don't need to externally install it. You see you have Python 2, Python 3, Scratch, BlueJ, which is a distro for Java, and various other options. You have some Office options also, and so on. So basically you get the idea. There is one symbol for Bluetooth, the symbol for increasing, decreasing the sound. This one shows the RAM usage, time, and so on. So it's quite similar to your normal Ubuntu based systems. So these Raspberry Pi GPIOs, or the general purpose input outputs, they can act as both digital output as well as digital input. It is quite similar to your input output, digital input output pins on the Arduino boards we covered previously. Okay. So if you pay attention to this thing, so these GPIO pins, these are a bit confusing. So I have included one chart describing the pin configurations. Over here, these two red pins are the 5-volt power pins. The black ones over here are the ground pins, and the remaining are GPIO pins. So you have certain GPIO pins which act as your UART, TXD and RXD. That means transmission and for reception. There are normal GPIO pins, and this chart or this configuration is very easily available online. So the basic setup for this Raspberry Pi, you will require a few components. First and foremost, when you are setting up the Raspberry Pi for the very first time, you will require an external monitor. You will require an HDMI cable to connect the monitor and the Raspberry Pi. You will require a keyboard and mouse, a basic 5-volt adapter to power up the Pi, a LAN cable, and your memory card, which will include the operating system on it. So we'll come to the setup a bit later. I'll give a demonstration of how to set up the whole system. So regarding the operating system, certain official distros for Raspberry Pi are Raspbian and Noobs, and some third-party OSs which can also be installed on the Raspberry Pi are this Ubuntu Mate, Snappy Ubuntu Core. You even have nowadays Windows 10 Core for Raspberry Pis, PiNet, and so on. So you can download your Raspberry Pi normal Raspbian image distribution from this link. Otherwise, you go on to this site, you search for Raspbian distribution. There are various versions, various releases. You select the most appropriate one, and that's it. And once the download is finished, you'll end up with a zip file. You unzip it, you'll get a image file, and you just write that image onto the memory card. So for Windows based systems, since most of the people use a Windows based system, the installation for this image is quite easy. You require a software called Win32 Disk Imager. It's freely available online. You run this disk imager software, plug in the SD card into your PC. You'll need an USB adapter for the SD card. You select the device, browse for the image file which contains that Raspbian image, and you just select write. So it will take around anything between 15 minutes to half an hour. So once your writing is finished, your memory card is ready to be integrated with the Raspberry Pi. So you can see, you just select the distribution or the image, the location of the image on your PC. On the right hand side, you can see you select the device onto which you want to write, and after both of these have been done, you just click on the write button. That's it. So now before coming to this step, let me give you a demo of how to start off with the basic Raspberry Pi installation. So over here, first of all, I have a keyboard and mouse. I'll just connect them to the USB ports. Choose any USB port. I have a LAN cable ready. I'm connecting it to the Ethernet port. This is a small monitor, portable monitor. So it is being powered by a external power supply, and it is connected. It will be connected to the Raspberry Pi via this HDMI cable on this HDMI port. So once all of these have been done, you just plug in your power supply for the Raspberry Pi. You already check whether you already have the memory card in place. So it is there, you just plug it in. So now if you pay attention on the screen, your booting starts. So once the boot is finished, you get a GUI based interface. So just like the screenshot in the previous slide, so you have got one terminal, you have got a start menu option, you can access various programming languages, you can access internet options, you have got options for mail, you have got options for other things. You can also set up a VNC server or VNC viewer on Raspberry Pi so that you can remotely access the user interface on the network. So once the Ethernet cable has been plugged, see this Ethernet has been plugged, so it is showing one IP. So this IP will be required to remotely access your PC, Raspberry Pi from your PC. So best practice is you go to terminal, right? Okay, one more thing, the default name for the Raspberry Pi distribution is Pi, Pi, and the password is Raspberry, RASPBERRY. So whenever you are remotely logging into the system, you give the username as Pi and the password as Raspberry. So first of all, I'll check for the IP of the system. So I give the command ipconfig. So you see various interfaces have been located. So I'm more interested in the first part. So this is going to be my required IP. So now I'll store this IP and I can remotely log in to the system using this IP. So now my Raspberry Pi is ready to be accessed remotely. So now I don't need to use the monitor anymore. So the main function of the monitor is to initially get the IP address for your system and for basic configurations. So coming back to the presentation, so initial configuration we have done. Now enabling this SSH option. SSH, as you know, stands for Secure Shell Login. So just check on your Raspberry Pi. Go again to the terminal. You give the command sudo raspi config and press enter. So you'll get something like this, right? Since I'm already using this Raspberry Pi for quite some time, this is not a fresh install, so all the operations have already been performed. But post first time installation of your Raspberry Pi, you need to expand your file system because these images are more or less compressed, and if you expand the file system, it will cover your entire memory card. So your entire memory card, suppose I'm using a 32 GB memory card, but the image was 2 GB approximately. So it will now expand to cover the maximum of the memory card. So you'll have lots of space for additional functions, installing new softwares, putting on files, etc. Okay, so once you expand the file system, after this operation is done, you reboot the system. So I'll go to advanced options. I'll go to advanced options. As you can see, there are various options for overscan, resolution, audio driver, and so on. And there should be one option for Okay, I'll go to interfacing options. Okay, for this distribution you have your enable SSH in the interface options under Raspberry config. So you select SSH and press enter, and once your SSH is enabled, you reboot your system. So this will allow you to access your Raspberry Pi over the network from any remote PC. From Windows based systems you can use software such as PuTTY or any SSH client. From Ubuntu based systems or Mac based systems you can only use the terminal to perform this SSH operation. So my SSH is already enabled. You can also enable your additional options, like if you have a Raspberry Pi camera, these are special cameras which can be integrated with Raspberry Pi. You can obviously integrate USB cameras via the USB ports, and there are, as you can see, there are various other options. If you need to use the VNC server, you enable this VNC option, and so on. So I hope you get the idea. So I'll escape this thing. Now coming back to the presentation, once the SSH has been enabled, so we have covered this thing. Then file system expansion we have explained. So as you remember from the live demo, this option was there, the first option, expand file system. So post this, as I've already told you, the basic default programming languages which are installed are Python, Java, C, C++, Scratch and Ruby. So more or less any language that will compile for ARM version 6 can be used easily with Raspberry Pi. So some basic and very popular applications you'll come across on the internet for Raspberry Pi based systems. Mostly they are media streamers, home automation systems, controlling a bot, virtual private networks, a lightweight web server for IoT. So like instead of having a dedicated big server for running IoT based applications, suppose you want to install a small IoT network in your home, maybe for home automation or home monitoring, you can obviously go for a Raspberry Pi based system. So this system will act as a server, whereas your devices will start uploading data to the server. You can even run various analytics on the Raspberry Pi based server, and then you obviously have a tablet computer based system. So this Raspberry Pi is already a computer, just interface a monitor and some external peripheral devices, and you're ready to go. Okay, so coming back once again to this system. So I don't require this anymore. I'll just close it. Now I'll do one thing. Let me access this Pi based system from my PC. I already have the IP. Okay, so here it is. So I'll write for my since my PC is running a Mac based system, I'll write the command ssh -y then space pi @ the IP address for your Raspberry Pi. So once I press enter, it will ask for the address. As I've told you, the default it will ask for the password. The default password is Raspberry. Once you enter the password, you're ready to go. First, it will give some basic information about the system, and then you'll see a prompt which will say pi @ Raspberry Pi. So that means you're ready to go. So you can just see your file system, what exactly are there. You can give a basic ls command or list file. So these are some of the directories or files within your Raspberry Pi. You can even remotely restart your PC or Raspberry Pi. So for the end of this lecture, I'll just reboot my Raspberry Pi. So I write sudo reboot, press enter. So as you can see over the monitor, my Raspberry Pi has gone into reboot. Again it is starting up. So this was the end of our part 1 lecture. Thank you.